first time working with the organic kit. So today I'll show you how we set up the organic kit and we'll perform our first lab investigating alkenes. This is normally about a 3-hour lab. I'll try to condense everything down into a short video. So let's just get started. Here we have our organic kit. So the first thing is to set up the apparatus. So let's start working on the apparatus before we get the chemicals together. Once we get the apparatus set up, we can collect our chemicals that will go into the reaction flask. So we have round bottom flask, 2 of those. I made sure everything was pre-washed, cleaned up. Attach those with some 3-finger clamps. This is just to show you normally how the apparatus will be set up. If you notice, there might still be some grease on some of the equipment here, because when we're done setting up, we have to grease the joints so that we don't have any leaks. So here we have 2 round bottom flasks, one for the reaction mixture, one for collecting the filtrate. We have the big condenser. Here is where water will run in and condense any vapor that's passing through. This adapter, this side is where we're going to have a thermometer so we can monitor the temperature of our reaction mixture. And then this other adapter leads to the collection flask. The rubber hose are to let water in and out of the condenser. So normally water in goes at the bottom. Connect that to a faucet. Turn it on so you can get a good flow. We want those pointing up. I'm just trying to get it sealed here. You can go with the flow a bit. Yeah, that should be fine. Now this is an oil bath. Normally we don't use flames in organic. It's much safer for us to use hot oil bath. So this is silicone oil. This is a hot plate and a stirrer. So the hot plate just keeps the oil warm or hot, while we have a knob that controls a stirrer, and a magnetic bar is inside, and that keeps swirling. So not only does it keep the heat dissipated around inside very well, but we can also use that to help stir the reaction mixture if we add a stir bar to the reaction mixture. before we move on, we're gonna grease the joints that we don't have to disconnect again. So we'll do these main joints first. Silicone paste is what we normally use. Some people just use Vaseline, that works just as well. Silicone paste is kind of more expensive, but it does the job. So all the joints where glass meets glass, we just want to put some silicone paste to make sure no gas escapes. So now we can focus on preparing the reaction mixture. So inside here we'll go, we want 10 cm cubes of cyclohexanol and 4 cm cubes of concentrated phosphoric acid. So we have our concentrated acid here. Cylinder. Cyclohexanol. If you notice, the viscosity of this alcohol is almost oily. So we'll put the cyclohexanol inside the reaction flask first. Then we'll slowly add 4 cm of phosphoric acid. Sour acid. Give it a good swirl, make sure everything mixes up. also going to take a smaller stir bar, add that to the reaction mixture, and we got to keep it mixing while we're doing the reaction. And we're just going to lower this part just so that that sits in the oil bath. And then we want to lower the rest of the apparatus so everything connects. Grease the final joints that we didn't grease as yet. Make sure everything is sealed. And that's it for setup. Now we're gonna monitor the temperature in the oil bath. Make sure it reaches between 70 and 75 degrees Celsius. So we want to monitor this thermometer here. We want to make sure the temperature of this solution stays between 70 and 75 degrees Celsius. That way we can start collecting our product, which will distill and evaporate off and then recondense here. So I'll get back to you as soon as we start collecting product. So we can go ahead and turn off the heat. We're going to leave that stirring. We're just going to lift this reaction flask out. Leave it here to cool off so we can clean up later. And then the product, we just loose this clamp. piston removed. Wipe away the grease, and we have our product. So let's set this aside while we prepare to purify the product. So first thing, we have our separatory funnel set up. So it's just a funnel inside a ring clamp and 250 beaker below the collect. First thing we want to do is to measure the volume that we collected. Remember, this is the impure product. We still have to clean and purify it. There's still a lot of water and other contaminants inside. It's just about 8.5 mLs. This is closed. 8.5 mLs of our product. And we're going to combine that with an equal volume of saturated sodium chloride. Also goes in there. So what that should do, water or any other aqueous component should mix with the sodium chloride, while the organic layer should separate. So you tap, you shake the mix. And our product should separate from that layer of sodium chloride. And there you can zoom in and see two layers forming. Now sometimes students might not know which layer is the aqueous or which is the organic layer. So what I suggest you just take a squirt bottle, and if you just add a drop of water, you can see where the water settles. So you can see the water goes straight through the top layer and to the bottom layer. So we know the top layer is an organic layer, the bottom layer is the aqueous layer. Now we separate, so we're just going to empty out that bottom layer and see the top layer. So I gently open this funnel and let that bottom layer run out. Try to get it as much as possible. Okay. Now that we have that separated, now we need to dry the cyclohexene. So for that, we need a conical flask. We're going to collect this organic layer. And to that, we're going to add our drying agent. Normally, we substitute the anhydrous calcium chloride for anhydrous sodium sulfate. So what this will do is any water that's still inside, you can see some bubbles to the bottom. Any water that's still inside will attach itself to this anhydrous powder. So if we just keep adding small amounts until the sodium sulfate stops clumping, then we know it's dried. So notice that's clumped up in that corner. We're going to add just a bit more to make sure everything is dried up. You have to stop clumping. So all the water should be attached to that anhydrous sodium sulfate, while the cyclohexene should be left behind. Now we're going to decant that solution into a clean round bottom flask, and we're going to redistill. Okay, so while we're waiting for that to redistill the pure product, we can move on and do the test with some cyclohexene that we have that's already been bought. That should show you what the results should actually look like. So the first test we're doing is the burning. So we have here a crucible, a clay triangle. We're just going to set that up over a Bunsen burner. Some ceramic wool, glass wool, or some of you might know it as fiberglass. Just want a bit of this. Ball that up. Put that inside the clay triangle. Inside the crucible. And we're going to add a drop of this, some drops of this cyclohexene to the ceramic bowl. Let's see what happens when we ignite. Again, you always have to be safe. A lot of organics are flammable. There you go. So the cyclohexene ignited. You can zoom in and see how long it's burning. The ceramic wool isn't burning, it's just the cyclohexene that's burning off. And it burns for quite a while. And it's almost done. Still burning a bit. I kind of did excess drops there. Still burning slightly. Okay, so while we wait for that to burn out, let's move on to the next step. Reactions with bromine. So I'll add 3 drops of cyclohexene to a clean test tube. 1, 2, 3. And then we're going to add 1 cm cube of dilute bromine water. So just 1 pipette, 1 ml. Notice that orange color of bromine water. Cap and shake. And the cyclohexene decolorizes the bromine water. That orange color is gone. Next reaction with permanganate. Again, 3 drops of cyclohexene. And then 1 cm cube of dilute sulfuric acid. We have that right here. Get a clean pipette. and also 3 drops of potassium permanganate. Purple color. We're gonna stopper, shake and mix. That purple color is changing, turning a bit brown. Precipitate is forming. Move on to the next reaction. The reaction with concentrated sulfuric acid. Another clean test tube. 3 more drops of cyclohexene, and then to that we're going to add 3 drops concentrated sulfuric acid. That clear liquid went yellow first and now it's going orange. And that's our last reaction with cyclohexene. You should be able to describe what is happening in those reactions. So all that's left now is to check our product. Let's see how far we've gone with that redistillation. Making sure to keep the heat between 80 to 85 degrees Celsius this time. And inside our reaction flask, we can see that it's almost empty, so we're going to be finished with this in a short while, and we can find our mass of product, and from there you can calculate your percentage yield. So I'll be right back to you as soon as we finish distilling.